Hello students. So in this video I'm going to show you how to solve the following equation, and not only solve the equation or try to find the solution, but also identify it as an identity, an inconsistent, or a conditional equation. Okay, just really quick, I'm going to cover what identity, inconsistent, and conditional equation are. Okay, so an identity is going to be an equation where the left side of the equal sign is going to be equal to the right side of the equal sign. So we're trying to solve for an equation and we reach something that looks like 1 equals 1, or 2 equals 2, or x equals x, or whatever, right? Negative 4x equals negative 4x. Then that equation is going to be defined as an identity. Okay, in order for an equation to be inconsistent, then it's going to be the completely opposite. Okay, so the left side has to be completely different than the right side, and this is not involving any variable. Okay, so if you reach something like negative 1 equals 2, that's not going to be true, right? Or 0 equals 10, or any number that you want to think about. Okay, negative 4 equals 8. Of course, we know all of those numbers are not going to be the same, so if we reach a situation that looks like this, then the equation is going to be inconsistent. Okay, and the last kind of equation that we can bump into is going to be the conditional equation. And the conditional equation, the result of a conditional equation, it's only going to be one result. Okay, or there's a condition that has to be met in order for that equation to be true. And this is a common equation that we know the solutions, or that we encounter more frequently, where we reach something like a variable equals 1, the variable equals 0, right? X equals negative 10, x equals 3/4, x equals, I'm just going to write it something, right? So x equals something, that's going to be a conditional equation. What does it mean? In order for that equation to be true, the condition has to be met, right? X has to be 1 in order for that equation to be true. X has to be equal to 0 in order for that equation to be true. Okay, so those are the different kinds of equations. So let's go ahead and try to solve this equation that we have in here and see what we bumped into as we try to solve it. Okay, so the first thing is I'm going to get rid of those fractions, of all of the fractions at the same time. So the first thing that I have to do, and you can take a look at my other videos where I go a little bit in detail into how to get rid of the fractions in an equation, is calculating the least common denominator. Okay, the smallest number that can be divided by 5 and can be divided by 3, or can be divided by 5, be divided by 5, and be divided by 3. Okay, so the least common denominator over here is going to be 15. Okay, so I'm going to take this least common denominator and multiply both sides of the equation times 15. Okay, and that way I'm going to get rid of those fractions. Okay, so first step, 15 divided by 5, that's going to be 3. And I'm going to keep all the top of my fraction. Okay, next step, 15 divided by 5, that's also 3. And I'm going to keep the top of my fraction, which is 6. And I'm going to do the same thing on the right side of the equation. Okay, so 15 divided by 3, that's going to be 5. And I'm going to keep the top of my fraction, which is negative 4x. Okay, now that we get rid of the fractions, we're going to try to get rid of the parentheses. We can use distributive property if we have a number in front of the parentheses. Okay, or we can use the rules of additions or subtractions if we have just a plus or a minus sign. Excuse me. So we're going to multiply 3 times 4x, that's going to be 12x. And 3 times 3, that should be 9. Getting rid of the first parenthesis. And we can carry over with this multiplication as well. It's not going to mess up our results or anything. Okay, 6 times 3, that's 18. And on the right side of the equation, that has to be a negative 20. 5 times negative 4, x. Okay, I'm going to keep going. Excuse me, I'm going to try to solve this equation. Now I'm going to send all the letters to one side and all the numbers to the other side. And I am deciding to send this positive 12x to the other side of the equation. And that way I'm going to have all the numbers in one side and all the terms with variables on the other side. Okay, so the only way to get rid of a positive 12x is if you subtract 12x. And if I do that, I'm going to subtract 12x from the right side of the equation. Okay, if you go ahead and combine like terms, those 12x cancel out. All I have in the left is positive 9 plus 18, or 9 plus 18. And on the right side, I'm going to add those two negative numbers, which happens to be negative 32x. Okay, if I combine like terms on the left side of my equation, 9 plus 18, that has to be 27 equals negative 32x. Now at this point, some people get confused. Okay, they think this is going to be an inconsistent equation because those two numbers, I mean, they're not divisible by each other's, or they're not going to cancel out or anything, but the reality is that this is going to be a conditional equation, not an inconsistent equation. Why? Because over here I can keep going. Okay, I can keep going. Can I divide both sides by negative 32? Yes, the answer is yes. Okay, I can divide both sides by negative 32. That cancels out my negative 32 on the right side and leaves an x equals, and then you have this fraction over here. Does this happen to be a real number, negative 27 over 32? And the answer is yes, right? So it means that the only condition that has to be met, or the condition that has to be met in order for this whole equation over here to be true, is that x equals negative 27 over 32. And that is a real number. If you go ahead and plug it in your calculator, that's going to be a real number. Okay, it's not just it's just not a whole number or a zero, or a simpler number, if you want to think about it that way. It happens to be a fraction, but that's perfectly fine, right? I mean, as long as x equals 0 or x equals 1 or x equals any fraction, right? It can be positive, it can be negative, it can be, decimals. As long as there is an x equals something, then the equation is going to be conditional. Okay, so it looks like this equation over here, the big equation from the big picture, that's going to be conditional. Okay, if we were trying to solve it and we would read something like x equals x, then that would be an identity. Okay, or if we read something like, I'm just going to play with the same numbers that we have in here, negative 27 equals 32. If we read something like this, then that's going to be an inconsistent equation, because negative 27 is not the same as 32. Okay, but if we have something like 27 equals negative 32x, that means that we can still solve for the variable which is x by dividing both sides by negative 32 like we just did. Okay, so this concludes this video. So please let me know if you have any other questions. You can reach out to me to my email, or you can reach out to me via Teams as well.